when someone says 2 power 3 equals to 8, so how we will represent in logarithms? Log, the base is, this is my growth rate and this is my output, this is what I want to be, and for that reason to become like 8, how many times I need to develop? So this is the time. So you can represent in this format, right? So this discussion, hope everyone understood by in last session itself we discussed about this. So now if you see, we have some laws in logarithms. So these laws will be helpful when you are solving and problems, and these laws will be helpful while converting one format, one representative to in easier format. Okay, so and sometimes you may end up with some notations like these words, and when you want to know which function is greater than and which one is lesser than, so in those scenarios also we will use logs basically. So don't worry about those things first. So now we will understand the laws. Minimum we have 4 to 5 laws we will try to explore. After that we will try to draw a graph using log. Okay. So if you see, if someone says 2 power 0, what will be the output of this? Normal. This is not log. 2 power 0 always 1. So when someone gives you an exponent or indices at 0, the value always will be 1, right? So 2 power minus 1, what will be the scenario? So this is a neutral scenario kind of thing. This is when I am saying minus 1, what does that mean? I am going backwards. This is growth rate, right? So here in this case neutral growth rate, but in this case we are saying I want to back in time. So that means my growth rate will be reduced, right? So this will be off. So how can you represent this same formula? Log, my base is 2, and what is my output? This is my output. Log base 2 of equals to minus 1. My growth rate is 2, okay, and this is my output, right? So what will be the answer for this? See here what I am saying, my growth rate is 2, and what I am expecting in some given amount of time, I want to become as 2. Already I am 2, already my existing position is at 2, and I want to become 2. What does that mean? That means 1, right? It always leads to 1. So my growth rate is 2 and I want to become as 2, that means 1 time, right? So if you can, this will be applicable to any number. 8, if I want to become as 8, 1. If log 5 is always 1. What does these notations telling us? It is my growth rate is 2 and I want to become the same number. So always the result will be 1, right? How can we represent in this notation? 2 power 1. What will be the value? Always 2. In this case, log 8 equals to 1. How we will do it? 8, my growth rate is 8, my exponent is 1. So what will be the result? 8 always. In this case, my growth rate is 5, and how many times I am doubling? 1 time. So what will be the output? 5 exponent 1 equals to always 1, 5, right? So I hope, see, irrespective of if both base and your exponent are same, the sum, whatever the expected output, what you want to become and the growth rate, if both are same, then always the value will be 1. right? So this represents your growth rate, and this represents what you want to become actually in given time, right? This is what logarithms, right? So this we discussed earlier. I hope everyone understand. This is my growth rate and I want to become a same number. So there is always will be the value of output will be 1. This we can translate into like this. 2 power 1 always will be 2. When you translate this 2 power 1 equals to 2 like this, 2 power 1 equals to 2, right? So how will you translate? Log my base 2 and what I want to become 2, so that exponent will come here. So I hope you understood now, right? So instead of 2 or 8 or 5, let's try to convert is a formula. What will be the, so instead of 2 some variable log z power z always equals to 1, right? Log, instead of 2 I am making it a z, instead of 2 I am making it a z. So log z of log base 2 of z equals to always 1. You can represent, you use anywhere, instead of z you can use a or n or whatever you like. So but the idea is, if you have growth rate and you want to become the same value, then always the output will be 1, right? Log 2 power what? 1 by 2 minus 1, and we have log z base z of z, both are same, always 1, right? So you can replace it z with a or some character, but the idea is, when my growth rate is z and I want to become as z, so this will be, when we translate, z power 1 equals to z, right? Or a power 1 equals to a. This means log a base a of a equals to 1, right? So this is, you need to remember these two things, and you can by your analysis, this also, see, when I say minus 1 I am going backwards, when I am saying neutral I will be 1, but when my base, my growth rate and what I want to become, when both are same, right, then obviously I will get 1. So as we seen examples, log 2 power 2, log 5 power 5, log 10 power 10, any number, so always will be, if both are same, always will be, the result will be 1, right? So now we will try to add logs, 2 logs, okay? For example, log 2 power 2 plus log 2 power 3. What will be my answer? Just take example. So what is this actually in normal representation? Log 2 power 2 what? See here, this is like log z power z, right? What will be the answer? 1, right? Plus log 2 power 3, sorry, log 2 power 8. Log 2 power 8, what is the value? How can you represent this one? My base is 2, so my output is 8. To become output, how many times I need to double? 3 times, right? 3 times I need to double. So here 2 power 3 equals to 8. So my question mark will become as 3, right? So now log 2 power 8 equals to 3, right? So here we got 1 and here. So 1 plus 3 should be 4, right? So now we got it, but we can do other thing also to get this output, right, very easily. What we can do, both are log base 2, right? So we will write log 2. Here my exponent is 2 and here my exponent is 8 and I am doing addition. So I can say 2 multiplied by 8. 2 came from here, 8 came from here. This log 2 is common in both scenarios. So what will be my output? Log 2. 2 multiplied by 8. How much? 16. Right? What is the value of log 2 power 16? My growth rate is 2 and I want to become as 4, 16. So how many times I need to develop? 2 multiplied by 2, 4, 4 multiplied by 2, 8, 8 multiplied by 2, 16. That means I need to double at 4 times. If you see, this 4 and this 4 are equal. Right? Initially I have 2 logarithms. One is log 2 base 2 and the other one is log base 2 of 8. So log base 2 of 2 is, the value is 1. Log base 2 of 8 value is 3. So when I add up these numbers, 1 plus 3 equals to 4. Right? My answer is 4. But in simple way, how can we translate? Both are base 2, log base. So now when I am adding any 2 logs, I can multiply the exponents. Here first my exponent is 2 and my second exponent is 8. So what I done here, log base 2, 2 multiplied by 8. So how much I got? Log base 2, 16. So my growth rate is 2. To become 16, how many times I need to develop? I need to develop for 4 times. Right? So if you replace, now what we will do is, we will replace with these numbers with some like z, whatever we done like this. So now log, for example, I have a log base a, for example, instead of 2 I have p plus log b q, okay, log a, log. So here if you see, this is p, this is q. This p represents this 2, this q represents this 8. Okay. So what we can do? What exactly we done? We multiplied the exponents. So this can be translated into log base a. This p here, my exponent is p, and in second log my exponent is q. So this is can be translated into log base a, p multiplied by q. Right? See, this is what we done actually. Log base 2, first exponent is 2, second exponent is 8. So we are simply multiplying when we are doing addition of 2 logs. So this is another formula, another law. So when you are adding 2 logs, okay, when you are adding 2 logs, you can multiply the exponents, the sum values, whatever you are seeing, right, these values p and q, you can multiply so that the value of this is equals to value of this, both are same. You will get the same value when you evaluate the functions, evaluate this function basically. I hope you understood, right? First, so when log z, when growth rate and what I want to be the value, or if they both are same, then we are becoming 1. When we are adding 2 logs, then we can simply multiply these values like this. So instead of 2, I represent it as a. Instead of 2 here, this is become p. Instead of 8, here it is a q. So what I am doing? Log a p multiplied by q. So whenever you see this kind of problems, we can simply use this formula. When you are adding, we can multiply these numbers so that it will be very easy to evaluate. So now we added 2 logs. But what will happen if we try to subtract one log from another log? So this is addition. Now we will see the problem of same problem, log 2 to same problem we will see. Okay. Now we will see the subtraction problem. For example, I have log base 2 of 8 minus log base 2 of 2. So what will be the output? This is the function we need to evaluate. So what can we do? We can translate. This is what? 2 power 3 equals to 8, right? Minus this is 2 power 2. So 2 power 3, this value is 3 minus this value is 1. So answer is 2, right? Because 2 power 2 always becomes 1. This is 3, 3 minus 1 equals to 2. But in the same way, whatever we done here when we are dealing with plus, we simply multiplied the p and q. In this case, for example, let's imagine log a p minus log a q equals to, here what I am doing? I am doing subtraction. When you are doing subtraction, it will become like this, log a p divided by q. So when we are doing addition, we multiplied. When we are doing subtraction, we are doing a division, p by q. Let's see how, whether it really solves our problem or not. Log a means here 2. So what is my p? 8 divided by q. Q means what? 2. So log base to 4. So what I got? Log base to 4. What is the answer for this? See, I am, as of now I am 2 and I want to become as 4. Okay, right? So what will be the answer? 2. Right? The answer is 2. This is equal as, same as when you evaluated previously. So normally what is the value? 2 power 3 equals to 8, right? This is 2 power 2 is 1 always. So 3, this is 3, this value will be the 3, 3 minus 1 equals to 2. So this value and this value are same. That means our logic is working, our law is working as expected. So just remember, when you are doing addition, we will multiply. When you are doing subtraction, we will do the division. So we will write up above. So what I will do, this is 1, this is 1, this is 1, this is another, and we have, when we are doing log a power p minus log a power q, what will be my answer? We can translate this into log a power log base a divided by p by q. So this is another law. Let's imagine we have log base a power p log base a power q. Okay, so if we have this kind of function, so what will happen here? What we will do? This answer will be, as we know, when we are doing addition, what we will do? Log a p multiplied by q, right? This is what. For example, just imagine here we have p, here we have q. Let's assume p and q value are same. Okay, let's assume P and Q are values are same. What will happen then? Now log A P plus log A Q. Sorry, P. You can use both same value, P or Q. So what will happen here? Log A. Here P and Q are same, so I can represent as P square, right? Right? So when we are doing addition, we know all this formula, but what will happen if, just imagine, if P and Q are same, then what will happen? Log A P plus the same thing translated as log A, instead of Q I am placing as P, and here log A, because P Q are same, so I can say P square. So this can be represented as, these are two logs, right? 2 log A P equals to log A P square. Okay. If you observe this, this value is here. Both are same. So that means instead of 2, if I place some another value, another character, let's imagine I am placing n. Instead of 2, I am placing n here. Log A P equals to log A P, instead of 2 I am placing the same n. So this is another log. If you clearly observe, so what does this mean? Whenever we have this kind of function, that can be translated like this, right? For example, if I have log 2 base 8 square, that can be translated as 2 log 2 8. So to make this our life simple, we always translate this kind of functions into like this, or based on if some requirement we can translate into this. That means this and this are same. That means we can use any one of the word based on our requirement, right? Based on our requirement. See, this scenario came when we are doing addition and the PQ are same. See, right? If you see like this kind of n multiplied by log A power P, log A P, that means we can represent this in another format like log A P power n. Log A P power n. Right? See, once again I will repeat, I have one equation like this, one function like this, log base A of P plus log base A of Q equals to, we know this, when we are doing addition, we will simply multiply this, log base A P and Q. So, let's imagine where P and Q values are same, then same equation can be translated as log base A P, log base A, instead of Q I am saying P because Q equals to P, P equals to Q. So what will happen here? Log base A P, instead of Q I am just imagine P, then P multiplied by P, P square. So now what happens? This can be represented as 2 logs, 2 log A P equals to what became log base A P power square. So that means when you see this kind of log, we can translate it into this way. So what we done, instead of 2 we placed n here, this became formula. So n log A P equals to log A P power n. So this is another formula. Okay, I hope everyone understood. Okay. So till now what are the laws we learned, I just will write down so that everyone will understand. So log, when you are doing an addition, what will be the answer? Multiply. Yes. Log A P multiplied by Q. So when I am doing a subtraction, what will happen? Yes, we will do a division. P by Q. So if P or Q are same in this case, what will happen? 2 log A P equals to log A P power derived from this addition. Okay, these are three. And what else? When we have log A base 2 of A is always leads to